Hi everyone, my name is Chai Sing Yi.
I am Wong Ro Yi.
Today we would like to present a physics lecture PSPM 2005-2006.
For question 1a, a 10 joule of work is needed to stretch an elastic spring by 2 cm. Calculate the work required to further extend the spring to 5 cm. When you apply a force to stretch a spring, you are doing work on the spring, and this work is stored in the spring as elastic potential energy. Therefore, we can use the formula US, which is elastic potential energy, equals to 1 over 2 kx squared. K is the spring constant and x is uh, the extension of the spring. So we can sub US equals to 10 and 1 over 2. K is what we need to find, and the extension of the spring is 2 cm, but we have to change it to SI unit, which is 0.02 meter. And we'll get the spring constant is equals to 50,000 Newton per meter. And by using this value, we can actually calculate uh, the work required to extend the same spring to 5 cm, uh, which is 62.5 joule. And the keyword for this question is to further extend, which means our spring is already extended to 2 cm, and we have to further extend the spring to 5 cm, which is 3 cm more. Therefore, we use 62.5 joule minus 10 joule, and the final answer equals to 52.5 joule.
Next, let us move on to the questions B. A woman pulls a 45 kg block at constant velocity on a rough surface as shown in figure 1. The angle between the rope and the horizontal is 30 degrees and the coefficient of kinetic friction between the block and the surface is 0.6. Questions 1. Sketch and label all the forces acting on the block. For the solution of questions 1, you need to draw a free body diagram. Just look at this diagram. T is the tension of the rope, so you need to label the angle given 30 degree. Then N is acting upward, which is the normal force of the block, while the Fk is the kinetic friction of the block. So you draw to the left because it's opposite to the tension. So for W is the weight of the block, so you need to draw downwards. Next, for the questions 2, calculate the tension in the rope. The tensions, which means that the force of the rope. So let's see the answer. Um, First of all, you need to do the summation of Fy equal to 0. Why the summation Fy equal to 0? Because the force is acting vertical. So vertical does not have acceleration and also the velocity, so it is F equal to 0. So the Fy is the vertical force acting on the block. So you can refer to this diagram. The vertical have the normal force and also the tension and also W. So you need to uh, write N plus with tension and minus W. So let us see on the equation. N plus T sine 30. Sine 30 is the angle and also minus W. W equal to mg. So you just sub m mass. You sub 45 kg in the m, and also g equal to gravitational acceleration. So you sub 9.81 minus t sine 30. So you get the normal force is equal to 441.45 minus t sine 30. Just leave it there. Next, you need to find the summation of fx equal to 0. Why the fx equal to 0? Because fx, the answer based on the questions, there is a keywords which that means that constant velocity. So the force is constant. So just fx equal to 0. So the fx is the horizontal force, let us refer to the free body diagram. So the horizontal force have tension and also kinetic friction. So you need to write tension T minus Fk. So let us see. T cos 30 minus Fk means kinetic friction equal to 0. So T cos 30 kinetic friction equal to coefficient times normal. So coefficient is given on the question, so you just sub it 0.6, and the normal force you have find before there, n equal to 1.45 minus t sine 30. So you can find the friction by times up the 0.6 with the normal force. Then the t cos 30 just left it equal to 0. Then you solve all the equation, then you will find T equal to 227 Newton.
Question B3. Calculate the work done on the block if the distance travelled at 3m. The solution for this question, we can use the formula work total equals to summation of Fx times S cos theta. Summation of Fx equals to 0 as stated in the previous question, and the displacement, which is S, is 3 and cos 0. And we get the final answer equals to 0 joule. And that's all from us. Thank you so much for listening.